In this video we shall talk about normalization requirements. It's good to understand and remember that during normalization process we can achieve both important goals. First, we may eliminate data operation anomalies, and that's good. And of course we may significantly improve the whole database quality. Now you'll see that there are a lot of normalization requirements, and it's really hard to comply with them all at once in a single database. But it's not the goal here. The goal here is to determine our main quality goals and follow those normalization requirements that bring us closer to those goals. So let's begin with the definition. Normalization is a process of decomposition of relation into projections, such as the join of those projections is guaranteed to be equal to initial relation. Then, each of those projections are needed in order to provide that initial relation. And at least one of those projections is at higher level of normalization than the initial relation is. We shall discuss normal forms in next several videos, but now we shall discuss those normalization requirements. The first requirement tells us to preserve subject matter constraints, because during that normalization we may divide some relation into new relations, and what if we lose something important here? Maybe we've forgotten some relationship, maybe we've forgotten some other constraint. We shall know all those subject matter constraints and be sure that we preserve all of them. Then of course we have to be sure that our database follows fundamental database requirements. If you've forgotten those requirements, please refer to the beginning of our course when we were discussing them. So that requirements are subject matter adequacy, technical usability, performance, and data safety. So our database should absolutely follow all those four fundamental requirements. The next idea is about primary keys minimality. We have to ask ourselves several questions. Does our table need a primary key at all? Of course, most tables do, but what if we have some table like some log or something like that? Such tables usually do not need primary key, so maybe we are in such situation. The next, is this primary key small enough? Because we remember, the smaller primary key is, the faster the table works. And what if we make our primary key too small? So is it big enough? Because primary key describes each record in a table, and if we have a lot of records, our primary key data type should supply those range of values. So the conclusion, can we preserve that data range while making the primary key smaller? Usually answers to these questions are rather simple, but nevertheless we have to ask ourselves those questions and get answers. The next requirement tells us to store data in single place only. Imagine such a bad situation. When we have two tables, we have some contract here and the same contract here with amount of money like this here and like this here. And we see that these numbers are different. If we store the information in a single place only, here for instance, such situation will never occur. The next requirement tells us to preserve general database performance. We have to analyze each table for some operations. For instance, with this table we have a lot of reads and few of writes and updates, so maybe we'll put several indexes here. That's a good decision. With this table we have few of reads but a lot of writes, so maybe we do not need primary key here, maybe we do not need any indexes here, and so on. And with this situation we have few of reads, few of writes, so we may follow either this way or some other way. Data consistency and integrity requirement tells us To create explicit relationships, never to violate such an approach, because some beginners in databases for some unknown reason sometimes violate this idea. Never do such a thing. Instead, use triggers, checks, any other constraint mechanisms that will make your database more bulletproof. The next, mind cache invalidation. Of course, this is one of the most terrible problem in programming at all. If you have caching fields or caching tables, you should absolutely know how to find out that cache is invalid and how to update it. And the main idea, all consistency and integrity constraints should be explicitly defined on database, not application side. The simplest explanation for this as follows. When we have a database, a lot of applications may work with that database. So once we implement all constraints here, we do not have to implement them in several applications, and we may be sure that no matter who develops an application with what quality he develops it, our database is protected by those constraints inside it. Each and every database evolves. In order to make that evolution process more easy, our database has to be flexible. So how can we achieve flexibility? With several approaches. The first approach tells us to follow naming convention. Compare those two situations. Here we have no naming convention, and this is a terrible situation. It's extremely hard to work with database with such names of database objects. But here we have good situation. We follow some consistent, some nice approach, and it's extremely easy to work with database with such names of database objects. So once again, follow some naming convention. Then of course use comments, because even if the documentation is somehow out of date or even somehow missing, comments are always inside the database. So in the future, you yourself or some of your colleagues may look into the database and understand what's really happening there, why one decision was made or another decision was made. So comments are good. Always use comments. And speaking about documentation, the documentation should exist. It may be small, it may be big, but it should be, and it should be up to date, because some ideas are hard to explain in comments and easy to explain in good documentation. And your documentation should include schemas. Of course, one may say that we may always auto-generate some schemas, but compare those two pictures. Here is auto-generated schema, so as for me it's rather hard to understand. And here is manually created schema with colors, with specific alignment, and so on and so on and so on. So this is not so good as this is. And the next idea is rather obvious. Always use some logical approach. Imagine that in some code you see the following script. When we create an index with two fields, and those fields are somehow limited with indexed length. Are these limitations necessary? Or maybe it's a mistake? Where are comments? How can we understand the source of this decision? Shall we leave it intact or change it? Will this change break anything? There are a lot of questions. If we had comments or good documentation, those questions will be somehow gone. But we do not have comments here, we do not have any documentation here. Instead, we have questions, questions, and questions. And it's hard to work in such a situation. And the last requirement is about data relevance or up-to-date state. If we have some aggregation, some caching tables or fields, we have to ask ourselves, how often should we update this cache? Are there any signs that data is not up to date, and what is that sign? And can we update this cache anytime we like, or maybe we shall wait for a good moment? We have to ask ourselves, these questions and many other questions about any aggregation and find out answers, and of course put appropriate technical decisions once we get those answers. And now, in next several videos, taking in mind those normalization requirements, we shall discuss normal forms.